Oh, right. Let's do something interesting. Let's try to get the memory map. So in UEFI, the UEFI spec, we have in the boot services, we have this get memory map function, and it takes a few arguments. So a memory map size, a memory map, well, a pointer to which it outputs the memory map, a map key, a descriptor size, and a descriptor version. I guess the most important thing here at first would be this memory map size, because this is an in and out variable or parameter. So on the way in as an input, this memory size tells the service here how big our memory map buffer is, so that it can write to it. On the output, so when this returns, this variable here will contain the size it actually wrote, or if the size we've given it is less than the size it needed, it will write in here the size it needs. So the way we are going to do this is first, or in the first step, we are going to set this to a 0, so that we are going to tell this function we haven't allocated any memory, how big the memory should be. It's going to let us know how big the memory is, or how big the memory should be. Then we will allocate that memory, and then in a second step, pass it the correct size along with the enough memory or a buffer that's big enough to contain all the descriptors. So let's do that. So let's go over here. I'll just create a new function. I'll call it get memory map, just something like this. And I'll go all the way down here, create this get memory map. It returns nothing. That should be okay. And since we now have our fancy logins, I'll just create a logger here that will be instead log scoped. And I'll create a scope. I'll call it memmap, for example. Right, so I guess first thing I will do here is just look at how the function is on the UEFI or Zig UEFI thingy. So let's just bring these things over here. And if we do boot services, get memory map. All right, so this needs a mmap size and a pointer to that actually. So yeah, that should be okay. It needs a map which is an optional many item slice of memory descriptor. It needs a pointer to this thing called map key, and it needs another pointer to descriptor size, and then it needs finally a pointer to descriptor version. There we go. So let's just create these first. So variable mmap size, this would be of type U size, of course, and this we will set to 0 for now. So and then we'll need mmap, and then this the type of this is an optional many pointer slice of UEFI tables. What's it called? Memory descriptor, I think. Yeah, and this I'll set to null. It's an optional, so I'll set it to null for now. And then we have map key, and map key is a U size, and we don't know the value of that, so I'll just say it as undefined for now. And then yeah, so then we have descriptor size, which is also U size of undefined value. And finally, we have descriptor version, which is AU32, and also undefined for now. Okay, so this here has never been used. That's okay. And I'm guessing that this returns a status like every other UEFI function does. So, so to handle that, I'll just create a var status here of type UEFI status, and this would be undefined for now. I think that would be cool. And then status here would just receive all the statuses that we are that we encounter. Right. So here let's do some error management or some error handling. So I'll switch the status, and here we are expecting a very particular status here that's called. I think it's this one here, buffer too small. So let's do that. So if it's buffer too small, then we'll what do? We do log.debug, and we will do something like need with this bytes for memory map buffer, and of course here we need to pass it as argument a map size. Yep. Of course this here. Else, if we don't get this buffer too small status, we should log an error. Expected buffer too small, but got string instead, and that string will be tag name of status, and of course this here just needs to be this. Right, so that's fine. Now that we have our memory map size, we need to allocate that size, right? So to do that, we are going to do to use boot services dot. I think there's something called alloc. All right, so we have the choice between pool and pages. I think I'll go with pool because we are not going to need to allocate a lot of memory. And it takes a memory type, so I guess I should do tables mem type. And what are the all right, so let's just use that. Actually, let me just get rid of this. Yeah. Right, so it needs a size, and that would be our mmap size, and then it needs a, well, basically it creates a buffer somewhere. So we'll just create the buffer where mmap is. So we will pointer cast a pointer to mmap there, and that should be okay. I guess this returns a status also, so status is that. Right, and we need to do the same thing here, so let me just copy that, paste it here. Here we are expecting a success. And if we change this, allocated the bytes at for memory map at address. So let's just use that. So this would be mem size and this would be mmap. That looks okay. Otherwise, expected success, but got something else instead. Right. So now that we have our memory to allocate or memory allocated for our memory map, we should just go ahead and do this again and call that again with the exact same parameters, except this time we actually want this to succeed. If we do, then we write got memory map with no arguments, otherwise success, but got that instead. All right. Now that looks very good. So functions should be camel case. All right. So let's build this and see what we get. All right. So let's run this now and see. Okay. Looks like we got the memory map. Let's try to rerun this again and see. All right. Let's try this again. All right. Let's now try it with a bit more memory. So go for 2 gigs. All right. That looks pretty good. So now let's do something with that memory map we got. So what I want to do here is I just want to print the memory maps or the memory map that we got. So I'll create a pointer. I'll call it descriptor. And this would be of type UEFI tables memory descriptor. Right, and I'll need this to be undefined for now, and then we'll do a let's also define an I index usize, which would be 0. So while index is less than, so we need to also have const descriptors count, and this descriptors count will be so a map size divided by descriptors size. Yeah, so while this is less than descriptors count, we will do index plus equals 1. And actually this, I don't know if this is going to work, but let's try it. So descriptor is equal to a map at I. At index, sorry. And that would make sense, and then we will do log.info. So we'll do something like this. Start and this in hex. Yeah, let's do something like this. It goes all the way to and in hex with a size of number pages, and we will also print I think there are other things on, so let's see what we have on the memory descriptor. So we have physical start, we have number of pages, which is the size, we have attributes, and we have type. We will ignore virtual start for now, because we know that anything that's mapped will be identity mapped, so we'll just ignore that for now. So I said attributes, so attrib is, and I'll set this to hex, and type should probably, something like this. Type is equal to string, and then we do something like this. There we go. And here we are going to go ahead and do descriptor dot type, or actually we need to take the tag name of that, descriptor dot type, and the other thing is the start. So descriptor dot physical start. Then we want the end, so descriptor dot physical start plus I guess we could do something like this, times descriptor descriptor dot number of pages, and then we have just descriptor number of pages, and finally we'll have descriptor dot attribute. And I guess this is also a an enum, so we'll go ahead and do int from enum. There we go. And what is this? This should be descriptor. And that should be it. Right. And let's see what we get from this. Oh, right. So does not support indexing. Okay. All right. So I've added actually a bitcast for the attribute because it wasn't, or it is not a an enum like I thought. It's actually pack struct with a U64 backend, so it just basically bitcast that to U64. So if we go ahead and build this again and try to run it with 64 megs of RAM, we get error invalid enum value. And actually we get expected success, but got buffer too small instead. All right. Actually, first of all, I might just do this and just return after any error, just to avoid weird stuff that can happen. So let's do that here. Turn, and this one here should be also handled like so. There we go. All right. So let's build this again and see. Again, buffer too small. I think what's happening is that by the time that we ask for the size of the memory map and we allocate something from the memory map, the size changes. And when we ask for the memory map with the original size, we get thrown out with saying that the size is not enough. So what I'll do is I'll just go ahead to memory size here and I'll add just about the size of two descriptors, so two descriptor size here, just to see if that solves our problem. Okay, so that does solve our problem. Now the issue we have is invalid enum value, and we also have what's this, 1 million pages? That's 4 gigs of RAM. Did I run this with 4 gigs? No, I run it with 64 megs. So that's not the correct value. Right. So let's see what we have here. Okay, there's something I want to try first. Let me just log something. Log.info. Descriptor size expected is this, and actual is this. And here we're gonna put the so we expect the descriptor to be the same size of the UEFI tables memory descriptor, right? So that's what we expect, and the actual size is descriptor size that we get back from the memory map, because maybe the memory descriptor not enum struct here that we have is out of date, or it's not properly aligned because it's not marked as backed. So I don't know. Let's try to see what we get from that first. Oh, wow. Okay. So we actually have a size mismatch between the actual struct and the size that getMemoryMap returns us. Right. That would explain why we get garbage data here, because this is definitely not valid data. Okay, so what I will do here is, instead of looping the array, should I say, instead of looping the array elements, what I'll do is I will take matters into my own hand, and I will just pointer from int, and that int will be index times the descriptor size, and to that we add the mmap pointer. So let's do int from pointer from ptr, and to that we pass mmap. Right, so let's see if this fixes the issue that we got. So expected pointer type found, yes, of course, and change this to be a pointer to that. Okay, it builds. Is that a good sign? Oh, wow. That is actually a good sign. Right, so we have quite a few. And looking at the sizes, they look okay, I think. Yeah, they look pretty okay, I think. But we have a way to validate this. Because if we quit out of our program and we go to the UEFI internal shell, which we will see in just one sec. Right, so we have it here in our console, and if we do so help, I think it's called memmap. Yep, there we go. So displays the memory map maintained by the UEFI environment. So let's do memmap, and here we can see what we have, what memmaps we have. So the first one is, I think these are in hex, so we probably should print our number of pages in hex also, just so that we can compare both of them. So let's do that actually. Just replace this with this, and we rebuild, and we see what we get. There we go. So here we are going to just run this. Oops. Yeah, so this one. And we get our pages. So let's just look at the first few. Here we have this that goes to 1000 with a 1 page. Then we have 9F 700 hex pages. And if we quit out of this, right, so that should open up our boot manager here. And if we go run EFI shell and do map, okay, so we are 1 off. So FFFF plus 1 would be 1000, so that looks pretty okay. I think the way we computed the size was 1 off, but otherwise I think it looks okay. The number of pages is 19F700831. If we go back here, 19F700831. And if we take a look at what's the biggest number of pages we get. So here we have C20 pages, boot service data, boot service data, C20 pages. Yep, that looks good. That looks good. So we now have our memory map. The only tricky thing is that since our memory map will change when we do allocations, and we are not maintaining it ourselves, we will need to leave getting the memory map and creating our the memory map that we are going to pass to our kernel for as far down the road as possible until we get all our allocations out of the way. Or if we know what to allocate, we can pre-allocate them and then do the memory map. But for now, we are just going to keep this code that prints the memory map, and we are going to reuse that memory map at the end just before we switch to kernel so that we can have a up-to-date memory map. Plus the fact that we get a map key. So if we go back to this here, we get this usize int, which is map key, and map key actually is very important because when we will call exit boot services, yep, there we go. So when we call exit boot services, we want to terminate the boot services. We will need to pass it a memmap key or a map key, and it will check that this map key is the latest map key that it has internally, that UEFI has internally. And if it's not the same, it will return an error status, and it will not let us exit the boot services. So that's why it's very important to have the very latest memory map just before switching to the kernel code. Well, that's pretty much it for today. We had a bit of an intro to memory mapping in UEFI. It's fairly easy. It has a few pitfalls, but it's fairly easy. It's a lot easier than memory mapping in BIOS. And you should know it by now. But if you like this type of content, please leave a like, a comment, maybe share this around to people who might be interested. And until next time, see ya. Bye.